So look at this guy. Yeah, standing there about 23 inches tall. Notice his hand is off. It's right there because I want to show you some stuff about his hand. This is not my design. This is another build I'm doing for somebody. I will do my best to remember to put the links in the description as far as where you can buy the files for this. I'm just printing it for somebody, and I decided to go ahead and do a quick video about it. Talk about the good points and the bad points, which there's really only a couple of, not even really bad points, just a couple of minor little critiques, and show you how it kind of goes together. And so yeah, let's get this guy laid down and taken apart and take a look at some of his features. Okay, so first off, the designer created some rather nice instructions. We have pages 1 through 6, and we'll just go through each page. And I'm not going to, spend a ton of time on each page. Just want to point out a few things. And first off, it lists all these screws here. So the screws, they even tell you here, they glue in 2 pieces. Here's actually the last screw that I have left to put together. So these screws, again, they just print in 2 pieces and they get bonded together. Again, I use solvent because now super glue would work. Super glue would probably work very well, but I have found that if sometimes with super glue, if it sets, like sometimes when you put super glue on, it'll like set like instantly kind of. And once that happens, you're kind of done. It's really difficult to reposition it. And as you can see here with the solvent, I was able to slide that around and get it repositioned the way I liked it. And before it starts to set up. And again, with super glue, if you put those together and it sets up on you, oops, it kind of slid, then you're going to have a hard time breaking that apart and getting it back together again. So I prefer the solvent. Plus, theoretically, solvent is as strong as the base material because it's like melting the stuff together. Now, with all of these screws, I have found it necessary to go in and just kind of clean up the threads like this a little bit, so that they screw in nicely. Got a few little goobers along the side here, and that's probably good for now until we put that in. I say that's good for now, and I keep going. All right, so there's one of the screws. All right, now let's take a look at the head. Here's what the head looks like. Now, all of these pieces are just snapped in. I did not use any glue in this at all. Those pieces just kind of snap and plug into place, and they are very secure. You could glue them if you wanted to, but for me, I didn't really see a need in it. The ball joint for the neck, for me, was a little bit loose, and there's actually a website where you buy the files, and I think there's a forum that talks about it. I saw something somewhere that talks about the joints, and he explained how he left clearances on all the moving parts and fitting parts, and I forget what it is. Like on ball joints, he had like I think it was like a 0 clearance or a 0.1 millimeter, something like that. Some of the other joints is like a 0.1 or 0.2 millimeter clearance. But he did say that on ball joints, if they're too loose, to coat them in, and this should just pull out like that, to coat them in fingernail polish. Now, I don't have fingernail polish. I mean, my wife and daughter do, but I really didn't want to try to explain that. So I just covered it with a very thin CA and let that cure, and tried it, and I think it took a couple of tries to get it tight enough that I like it. So a few layers of thin CA, and then that's pretty good. Now, if you hold it and it just flops, then it's too loose, obviously. You want it to move nicely, but not just flop around. And again, one thing about the designer of this, again, all these parts, well, not all, most of these parts just snap together with very little effort. You will need a little bit of sanding and finessing on a few parts, like the next thing I'm going to talk about, and that is the fist. Now, the parts for the fist, they all print as one thing. Well, there's 13 individual parts, but they print in one file. And one of my, I guess, gripes is that all of these finger joints down here, here's one of them, they print standing up vertical this way. So I put a brim around it, and so it prints on that surface right there. So it prints standing up like that. And I don't like printing parts that have a very small surface area to height ratio because they tend to fall over and get messed up. So I put the brim on it, and to help prevent them from screwing up or falling over mid-print, I also enabled Z-lift. So as it's printing, the extruder will lift, go to the next part, down, and keep printing, lift, go to the next part, and down. And I think that helps keep these things from falling over. Because otherwise, when it drags from one to the other one, you know, as it comes across this one, it could hit it and break it off. So by lifting, going over and back down, printing, lifting, over and down, it makes the print take a lot longer, but I think that helps us print with more success. So to take the brim off is pretty simple. And these are some of the parts where you will need to spend quite a bit of time getting them to fit. At least for mine, I did. I got a little bit of a stringing in here. But inside of here is going to take a lot of minor little slicing. Right along here. Each side there, like so. And again, what I'm doing here is not nearly enough. And I know because this is like the last finger. So you're going to have to clean out the little pocket in here. And then on the center knuckle, we'll get the brim off of that one. And be careful here, as I have not been careful. I stabbed, see it? That finger right there. That thumb right there. That thumb there. Yeah, it's, I know. But when you're cleaning up parts this small with a sharp blade, it's, you know what you should do maybe, or what I should do maybe, is put my Band-Aids on first. Put my Band-Aids on first. That'll save a lot of time. But these are too thick, left or right here, so they get carved down this way. Now I could sand that, and actually I'd do a little bit, but I carve it down first, and then I'll go through and sand. Also, when I'm printing parts, well, my parts, when they print, was a marker. Instead of getting a nice, like, sharp corner like that, I'll get a corner with a little thing like that. And that has to be kind of cut off. Does that make sense? I don't know if that's just me or if that's common. I by no means want to claim to be an expert when it comes to 3D printing. These are just some of the things that I deal with on mine. I guess if I ever get another printer and I see what it does, then I'll know for sure if that's normal or not. Of course, you guys can leave a comment and let me know. Maybe there's some kind of a setting I can use that'll correct that. And that was just, you know, a way for me to tell you to leave a comment. Now, what I did there was not near enough, but you get the idea. And that, once I do enough, I said do. Once I do enough, that will just slide in. You can see there that it's a little bit not enough. It's still a little bit too tight, but that will slide in and snap in. Let me show you a finger that's done. See that? Right there. And it does take a lot. Now the ball joint part, the other end is more of a ball joint. That does snap into there rather, well, I won't say easily, but you don't have to do any sanding or carving there. You can push that in, it'll snap in and lock in place. It's that middle joint right there that needs all of the work. Also the thumb here, same thing with the thumb, but you have one joint here and one joint here, and then another joint that moves this way. So there's like 3 joints in the thumb. All of those need a lot of work and a lot of sanding. And then this piece right here, that piece right there, that also needs quite a bit of work to get that to go in, snap in, and then be able to pivot. All right, but minus that little bit of carving and sanding on these things, these hands are really cool. I'm really liking those. So let me get these fit, and then we'll get back and put it together and show you what the finished hand looks like. Okay, those should be good now. And that goes, yeah, like that. Now you don't want it so loose that they just fall together, because then they'll fall apart. So a little bit of, yeah, there you go, a little bit of wiggle back and forth, and then so yeah, there, and then there you got the joint. Work it back and forth a bit to loosen it up, but there's another finger done, and then that should just push right into here. Oh, you know what? I did say you don't need any sanding on there, but you do got to make sure that all the flash, not the flash, but the brim is removed. I did not try printing the hand without a brim. Normally I don't use a brim. Normally everything works fine without a brim, but like I said, if it looks like it's going to fall over during print, I will put a brim on it. That doesn't always help. I have still had tall parts fall over even with a brim, but I think it's better, less likely than without. Right in there. And that'll go all the way to there. There you go. Now, all right, well, let's look at the next page. Move that over here, move that over here. Page 2. These are some of the biggest, bulkiest parts, and they print easily, they print nicely, but some of these take a long time to print. That main part took 13 hours. That took about 8 hours, it looks like. That one took about 9 hours. Let me get the body part out and take a look at that. Okay, so here's the main central part, body part. And it has the his little dump truck backpack here. That's actually on a different page, but it's snapped in there. And I don't want to take it out because I don't want to risk breaking it. I don't think it would, but you know, I don't want to take the chance. Here's where the head plugs in. That little piece lifts up. It's kind of like a neck, I guess, kind of like a secondary kind of a neck. So that lifts up. Of course, the head plugs are right there. Now, got some shoulder joints. Now the screws. So here's a screw that holds on one of these shoulder joints. And the shoulder joint, just have those pieces go in like that. And then that plugs in here. And then you screw that down. And when you lock that down, it locks the shoulder joint in place. Now these work very well for locking the shoulder joints. Some of the other joints don't work as well. Some work better than others. I'll show you some of the ones that don't work very well. Those can be a little hard to turn. I might make a tool to grab that and turn it with, maybe. These front pieces here, there's 3 pieces here. Those snap on very nicely. The window here snaps on very nicely. There's a little hammer claw piece that plugs in right there. That fits pretty nicely. The body part, this part here, flips back and forth so you can bend at the waist. The screw to lock that in is right there. So you turn this and it will lock that in place. And it's a fairly simple mechanism. We take that out. It's not really a screw, it's more of a nut. And that goes on a threaded piece that then pulls apart onto two balls. I don't think I want to pull this apart. No, I could. There you go, just like that. So when you screw that nut down, you can see what happens here. It pulls that in, and then that squeezes those two balls. All right. Notice I did not make a crude comment about that. I guess I just did. They put their website here, Toymaker 3D. And of course you can turn that tight and it locks that down. Is that in all the way? Yeah, has to be. All right, and now the lower waist, we have the two hip sockets here. Those pieces flip up and down. I got the front part. Those pieces kind of move. Yeah, they move. Those open up. So you can completely fluff up his skirt right there. And of course the leg sockets, legs plug onto those. And this, the way the hip here locks in, you've got this piece, and notice there's a little slope on that side. That slope goes across the top slope there. So when you tighten a screw, it squeezes those together and locks it in place. So that then goes in like this. Don't think I lost that piece. So that goes in, tightens down, and you tighten that up and that will lock his pivoting of the waist. There it is. Wasn't screwed in all the way. There we go. Now that waist is locked in. And there's his center body. So the main mass of his torso, all of this took a long time to print. Okay, what's next? It's page 2. Page 3 are the arms and the hands and the fists. Take a look at the right arm. Right arm is looking just like this. Again, the windows, they just plugged in. The tracks just slide in. We'll talk about the screw and the lock a bit later. The elbow, loosen that screw, and the elbow is nice and loose. Tighten that screw, and it locks the elbow in place. Kind of. These are one of the locks that don't really work all that well. It tries to, but you just can't get enough friction on these plastic parts to really lock it in really tight. I mean, if you crank that screw tight, yeah, it's a little bit tight. It'll hold its own weight, but those could be better. I don't know if maybe they could have put some teeth in there, maybe just had it ratcheting on teeth maybe. I don't know. But here we can now put the hand in. Hand goes in and then slides on one. Just like that. There we go. Some of these parts are pretty tight fitting. Not gonna lie. And I just realized once that's in, sounds like flipper. The wrist really doesn't have that much movement in it. Get that knuckle back in there. Because if you try to, well, maybe you can, I don't want to break it. There it goes. Okay, for some reason it was getting jammed up. So the wrist can flip back this way or up. It cannot go this way. It can go like that or like that, and that's it. And of course it'll rotate like that and like that. Now the way the arm locks in, you got the screw, and as you screw the screw in, now this goes in here. As you tighten that screw, it's going to push I need to fix those threads. It pushes that plate in, which clamps it on right there. And that's what's going to lock that shoulder joint. Yeah, I got to fix those threads because that's way too tight. And there's my finger stabber right here. Now, printing wise, I made this screws and any other part that I thought would be stressed. I made those with about 4 perimeters and a really high infill, like 40% infill. Other parts that don't need to be that strong, 3 perimeters with a 20% infill. Don't really think it matters too much. I mean, the screws are under a lot of stress, so they need to be fairly solid, I would think. And I'm just going to go through. And let's see, this one is the right arm, so that's going to go right here. Yeah, it screws in much better now. So you got to get under his armpit, tighten his shoulder there, and then you can tighten back here. So it's a little bit awkward getting to some of the parts that you got to tighten, but it's doable. The other arm, just like that one, only it's a different type of a truck bulldozer implement. Got a little front end loader here. By the way, I don't know if I specified this or not, but this is not called Devastator, it's just called Bulldozer. Probably did that for reasons. Let me get a different lens on here so we can start to see, because this is getting kind of big. Get that lens on here, that might help. So yeah, when you get the file for this, it's specifically called Bulldozer, not Devastator. But this arm is going to go on just like the other one. Here's that other elbow lock right there. One of my other, again, I don't want to call it a gripe, critique is a good word, is this blade just pops off really easily. Now I know this is to be put on a shelf and looked at, not really played with, but that pops off really easily. That moves nicely. So let's go ahead and put this in. Yeah, that screw needs some work as well. Let me tidy up the threads on this one. Okay, by the way, that little locking piece, when this prints on the bed, that is face down on the glass. So when you pop it off the bed, that's going to be nice and shiny. It's hard to get friction on a nice shiny plate, so I rough it up with some 50 grit sandpaper. That will help it get some friction on those parts. When you lock it down, it's going to lock down a little bit tighter. Now, I had a great idea, but I'm not really smart enough myself to know how to do it. I don't even know if it already exists or not. But everybody knows about grease. If a joint has too much friction, you put grease in it and you're good to go. But what about a joint that doesn't have enough friction? There needs to be some kind of an anti-grease. Now, I know valve grinding compound would work, but valve grinding compound would also eat away at the material. You don't want to do that. You don't want to grind the material away. So something that's like grease, and when you put in the joint, it increases the friction. That is still too tight. I'll fix that later. Actually, that did get pretty tight there. So I think that's a good idea. If any of you out there know how to do that, and you make it, and you make a fortune off of it, just remember me, all right? Keep me in mind. Okay, so there's the body with the arms on it. And I think what's probably next is the legs. Nope. The backpack you already saw. The lower waist is made up of multiple pieces. You kind of already saw that. That's all of this right here. The gun, the blaster. So this guy right here. Pretty simple and straightforward. It's in 2 pieces. Just goes together. I'll glue that later so it doesn't fall apart. So that'll get glued. And notice the little posts on the handle. those go into the hand here. There's little notches in the hand so he can hold. Let's see if we can get this in there. It tries to. There it goes. And close the fingers around it. There you go. So he can hold his weapon. That's not perfect in there, but you get the idea. Let me put this away and we'll take a look at the legs. Okay, let's look at the left leg. Here's the whole leg here. And it's like a cement mixer type of thing on it. And again, all the parts are pretty straightforward. They print pretty nicely. There's a screw here that will loosen a ball joint for his foot. Of course, to tighten that, to lock that joint. You got a toe that flips up and down. You've got this piece that moves up and down. I don't know why exactly, to be honest with you. There's this piece that slides up and down that kind of moves with this. I'm not sure why they did all that. You've got the knee. Again, you got a screw here that loosens the knee. That can flip back this way, like that. And then tighten that up to lock the knee. Again, this one, it's kind of hard to get. Well, it's a little tighter. It'll definitely get loose. It'll definitely get loose, but you crank that pretty tight and it can still move. Yeah, that's just, again, one of the things about these locks. They work-ish, you know. And then, of course, at the very top, you've got a swivel here. And you got the ball joint that goes into the hip sockets that we just saw a few minutes ago. And right back here goes one of these little short screws. And that goes right in there. And as you can see, maybe if my lighting was better, right there, that's going to grab onto the ball and lock that socket. So you can loosen that up to loosen up his hip joint, and then tighten that up to lock it up. So there's that leg. Oh, my other critique. This piece right here and these two pieces are on the same STL file. Those three pieces print together, and it's all part number 61. So you got that part 61, those two parts 61, and my complaint or critique, I shouldn't say complaint. I mean, again, this is an incredible model. But let me show you something. These two pieces here, right here, when they print standing up vertically. And remember what I said earlier about those finger pieces. Tiny little contact point, really tall print. Well, this was the first attempt. This one almost made it, but as you can see, that line here, what happened as it got up about that high, this started moving a bit. It started pivoting a little bit. I tried super gluing it back down to the bed, but it wasn't enough. This one got all the way near the top, and then it just started wiggling around. This thing was like a loose tooth. Every time that print head came along, it would just wobble it and wiggle it all the way around. So what I did was I reloaded part 61 into my CAD program, which I'm using SketchUp, and I basically got rid of this one because it printed fine the first time, and I repositioned these so they printed this way. That required some support material around here, but that was easy enough to break off, and then they just snapped in here. I didn't glue them. I don't need to pull them out. They snapped in pretty tight. I don't want to pull them out and risk breaking them. But, so I printed them this way. Again, it needed support material, break the support material off, and then they just snap in place. And I think that was the only part that actually needed support material. This whole thing was designed to be able to be printed without needing support material. But because I reorientated those, I needed support material. And I'm only assuming that he originally had it print vertically, so you wouldn't need support material. Now, I did not do the Z-hop or the Z-lift with those. Maybe if I would have tried the Z-lift, they would have printed fine. So maybe try that first. When you print yours, when you get to that part 61, enable Z-lift and maybe those will come out okay. Otherwise, you might have to do what I did. So there's that leg. Put that away, and we'll grab the other leg. The top joint here is the same as the other one. The knee joint is pretty much the same as the other one, but now we have a different foot that pivots here, and these, they just fall off, so I'm going to glue those on. And we have a screw here that loosens the ball joint right there for that foot. Tighten that up, and that makes that a lot tighter. It doesn't completely lock it, but it definitely makes it tighter. But yeah, this one's, yeah, I'll glue both of those in, because it will fall out on its own weight, and it shouldn't do that. So those two will get glued in, but there's that for that leg. So let me put this all back together again, and we'll wrap this video up. So there he is, all back together again, standing up, trying to block out my messy background there, so you can see him better. But yeah, what a cool model. Again, to whoever designed this thing, just an outstanding job. This was a joy to print, a pleasure to put together, except for the hands. They were a pain in the butt, but they came out very cool. Everything about this thing is just very cool. And so much posability too. I mean, yes, some of the joints don't lock very easily, but once you get him into a pose or a position, he'll hold it pretty well. It is big. Again, like I said, it's about 23, 24 inches tall, somewhere in there. So it is a little bit tough to manage. Sometimes it feels like you need 3 or 4 hands just to kind of move him around and pose him. But anyways, I'm going to end this here because I'm just rambling. I just thought you guys would like to see another large 3D printed project. And like I said, I will try to remember to leave a link in the description in case you want to download the files and print it for yourself. So yeah, I'm going to end it here. So as always, thanks for watching.